So today we're going to continue using trig and right triangles. We may not see them today, but we will be using them in this section. Now, an application of trig ratios, the sine, cosine, tangent, is dealing with area of what's called a regular polygon. So we have some vocab that we need to chat about first. First is, well, what is a polygon? Simply put, a polygon is a 2D shape with 3 or more sides. And we've been dealing with a particular polygon. In fact, the polygon that we've typically been dealing with is a 3-sided shape, also called a triangle. Now, we are going to need to know the names of other polygons, because that's going to tell us the number of sides they have. For example, a 4-sided shape called a quadrilateral. Quad being 4. 5-sided shape is called a pentagon. A 6-sided shape is a hexagon. A 7-sided shape is a heptagon. An 8-sided shape is an octagon. 9-sided shape is a nonagon. A 10-sided shape is a decagon. Deca like decade. And a 12-sided shape, yes, we skip 11. A 12-sided shape is called a dodecagon. So let's identify what these shapes are. Looking at example 1a, this shape has 1, 2, 3, 4, 5 sides. So this is a pentagon. B, well, let's count the sides again. So it has 1, 2, 3, 4, 5, 6 sides. A 6-sided shape, so this is a hexagon. C, well, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is a decagon. Like a decade. Go ahead and try doing the fourth one. Fourth one, we have 1, 2, 3, 4, 5, 6, 7 sides. So this is a heptagon. So we will need to know what these shapes are called. In fact, we have some more vocab dealing with these. So those shapes above were polygons, except C and D were special types of polygons. Those are called a regular polygon. A regular polygon has all angles and sides congruent. So every single side length is the same, and every single angle inside of it is the same. Typically in this unit, we will be dealing with regular polygons because we can actually find the area of them. Well, in order to do that, we need to find what's called a central angle. And we are also original in naming things because a central angle is an angle in the center. So if we look at our pentagon off to the side, our regular polygon pentagon, that angle in the center is our central angle. In fact, we will be looking at, starting tomorrow, how to find that central angle. Second thing is a radius. Radius is from the distance from the center to a vertex, or an actual angle. So in other words, this length right here, where we go from the center to the vertex, is a radius. And then, new word for the day, the apothem. It's like trying to say opossum, like the animal, but with a list. So apothem. The apothem is a perpendicular distance from the center to a side. So from the center to a side, perpendicular. So that is our apothem. A lot of times we just shorten it down into A. So let's actually figure out what this formula is to find the area of a regular polygon. So there's a couple things that we need to know. So first, I'm going to draw in my apothem again. So going from the center, perpendicular to the edge. This is our A. The formula for area of a regular polygon so capital A is area, equals A N S divide 2. A is our apothem. N is the number of sides. And S is side length. So those are the three things that we are going to need to find the area of a polygon. So let's look at a couple examples. Now, when I see a polygon, just like how we had for a right triangle where we labeled sides, I'm automatically going to, off to the side, put A equals, N equals, S equals. So this way I can put my things where I see them. So A is our apothem, so the distance from the center perpendicular to an edge. So in this case, it's 13.7. N is number of sides. Well, the shape has 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So my N is 9. And my S, my side length, well, I see one side is 10. So in this case, I have all things that I need to find my area. So area equals our A, our apothem, 13.7, times our N, or our number of sides, so 9, times our side length, or S, so 10, divided by 2. Now, if you type it in exactly how it is written, parentheses 13.7, close new parenthesis, 9, close, parenthesis, 10, close, divide 2, the calculator will spit out your answer for you. In fact, it spits out the area being 616.5. Now, we don't have units of measure in this problem, so I'm not going to worry about inches squared, feet squared, or whatever. I'm going to, for number 2, automatically write A equals, N equals, S equals. Go ahead, try doing number 2. So on number 2, our opossum distance from the center to the edge is 9.6. N number of sides, well, this shape has 1, 2, 3, 4, 5 sides. And our side length is 14. So in our calculator, we can type in 9.6 times 5 times 14 by 2. Doing so, we should get 336. Once again, no units of measure in this problem, so we're not going to worry about it.